In this short series, I'll be going over a few frameworks and concepts that are necessary for successful data strategy. And what we'll do, we'll start with this question of what data characteristics and flows are required for successful data analytics. Think of this as the prerequisites. What do we need just to get out the gate in order for this to be successful? Now, unsurprisingly, for your new data initiative to be successful, in your new data science or data analytics initiative to be successful in your company, the first thing that you need is data. In order to get this data, first we need to generate it. Now, where could it potentially come from? Well, lots and lots of sources. In fact, a lot more than you think. So there are internal sources, there are also external sources. And internally, you could think of this as the obvious. Say, transactions, your financials, your inventory, interactions with customers. But it also could be more sophisticated things like audio recordings at one of your call centers. Externally, you could think of social media. There are data service providers out there. There's the Bureau of Labor Statistics and lots of other government entities that are providing data that's out there for you to use. So first of all, we're generating this data both internally and externally. At that point, we need to manage this data so that we can actually use it. Now, in data management, what do we care about? One, well, it needs to be stored. Otherwise, we generate the data and it just gets lost. And second, we need to be able to access it. Because if we store it and don't access it, well, then we're just hoarders that can't access our own stuff that we have. And the third is speed. If we've stored it and we have access to it, but it's going to take forever to access, well, then we might not end up using it even though we have it and could get to it. So storage, access, and speed are three important dimensions to remember within data management. And within data management, you'll read or hear or study a lot about data warehouses and data lakes for structured and unstructured data. There's a lot of information out there about data management and how it's done properly. And finally, so if you've generated the data, you're managing the data, finally you can get to your data analysis. And for data analysis, what are we focusing on? Well, we want actionable insights. Not cool models, but actionable models that actually deliver value for the company. We're going to create value and capture that value. And we're going to do that by generating models and generating insights that we can actually deploy. Now that we've talked about the flow, what are the characteristics of that data for it to actually be useful? Well, the first, you can think of this as ARC, A-R-C. The data ideally is accurate, reliable, and consistent. So accurate just means free from errors. So GIGO means garbage in, garbage out. So if you generate terrible data, you're much more likely to generate terrible models. Now, that's not always the case, and we'll talk about that in a later video. But accuracy is extremely important. Second is reliable, and this means that the data source is dependable. So let's say that we create a model that's using a certain data source, and it's a very, very good model, but when we try to deploy it tomorrow, that data source is now gone. We can't use it anymore. So now what? Well, we might as well not have the model in the first place if we're not going to have that going forward. Are the data sources dependable and reliable? And the third item is consistency. Data is captured in the same way every time. So if data is highly accurate, very reliable, and consistent, that is ideal data. Now, if we have this ideal data, and of course we don't live in an ideal world, and we frequently don't have perfectly accurate, perfectly reliable, or perfectly consistent data, but frequently, let's say it's good enough. So then we get to this match between the data and the insights that we need. Now, a company doesn't want just data, they want insights. An organization has specific questions. They want to drive certain value. They want to deliver this value to customers. And so does this data, can we convert this information that we have and convert it into insights, into actions? Are we going to actually change our decisions because of this data that we have? And the third is data features. So let's say that we have ideal data, that we have a match between the data and the insight. Like, okay, so this data should match this question. Well, we need data that's specific enough, has a richness of features in the data set, so that you can provide answers that are beyond just the obvious answer. And so if you have a very, very basic data set that doesn't have a lot of features in it, you might say, hey, look, when customers, I've actually seen this before, oh, when customers are happy about their experience, they're more likely to come back. And of course, what's the response to that? Well, no duh. We already know that. Now, a data set that's rich in features, you might say, hey, when we fail on these very specific dimensions in a customer transaction, they're not going to come back. Those are the deal breakers. So it's not just generally I'm unsatisfied, it's I'm unsatisfied about exactly A, B, and C. And so those are some of the optimal data characteristics. So it needs to be ARC. We need it to match, the data needs to match one of the insights that we need. And the features of the data set need to be rich enough to actually answer it in such a way that it's going to add value. Now I wanted to zoom out for a moment and let's take a look at the big picture. How does this actually look within an organization? So let's say this is typically how, say, a data analytics initiative can go. So you have data engineers or administrators that they're going to securely provide this data. Ideally, it's efficient and complete. These data scientists, to your data science team, your data scientists will create models. Ideally, they're using kind of these working use case models. They're also going to probably be suggesting new or improved data on how they could improve these models further. Frequently, there's a translator. This isn't a specific role within an organization, like a title probably, but it's someone who can breach the geeks and jocks divide, so to speak. And what they'll do, they'll be working on validating the model and communicating these suggested changes. Then management is going to be implementing, making decisions based off of this. And they'll be then providing feedback on feasibility. They'll be proposing potentially high-value use cases to the data scientists. And they'll also be going back to the data engineering team to create additional data sources. And so that'll be with both on the data side and probably operations as well if it's internally generated data. Now, this is the general overview for kind of how that flow works, but where do we start? Let's say I want to start this from scratch. Where do I focus on first? And really where we need to focus is management proposing potentially high value use cases. Now, why? We want to implement and use this data and implement models to actually create value. Who's most likely to know on what's going to create value for the customer? Well, it's going to be operations frequently and a lot of the management team. They know what customers want. They're hearing this feedback. They have an idea of the value that they want to create. And so as they're proposing these high value use cases, that's where you can start this feedback loop where they're proposing a high value use case. There's some success on that, and so we'll improve it and go get more data or better data or make some adaptations in order to start generating more and more value for our customers. Now, it's important to recognize that this is iteration. It's not a project. This data analytics initiative that we have is not just a project. You can't just milestone it out and on day one, the data engineers will do this, and on day two, the data scientists will do this, blah, blah, blah. That's not going to work. You need an iterative process because you're going to be constantly needing to tweak, change, and improve every step of the way. This is a flow. It's an iterative flow. So a recap of what we've covered today. First, you need to make sure that your data flows are actually in place and they have the right characteristics for successful data analysis. And if they don't, well then how can we blame the models when the data say it's bad? Next point is that management is key to success because they are the ones who generally know the high use cases, the high value cases. And also in the end, they have the final say. If they want to axe this entire project, if everything's going great, but management just doesn't understand it or see it, well, they're going to kill the program no matter how successful it is because they don't see the value of it, and they're the ones making the budget decisions. And finally, we need to set up these agile flows that are responsive to the needs of an organization, and recognize that a successful data analytics initiative is going to be iterative, not just a one-time project.